Crude oil is found in the Earth's crust. Which of the statements about crude oil is correct? Crude oil is a finite resource. That means it will run out one day. Yes, it definitely is. It's non-renewable. Crude oil is a mixture of the elements hydrogen and carbon. No, it's a mixture of hydrocarbons, these types of molecules, not all elements separated. All of the molecules in crude oil contain rings of carbon atoms. No, they contain sort of long strands of carbon atoms. Crude oil is used in cars as fuel, not unless it's processed into petrol, so not raw, no. So crude oil is a finite resource, it will run out. Crude oil is basically a mixture of hydrocarbons. Hydrocarbons are molecules which contain long carbon backbones and hydrogen bonded to each of the carbons, like so. The length of the carbon strand can change, and that affects the properties of the chemical in there. The substance is ethane, C2H6, so that would mean 2 carbons make up the backbone and 6 hydrogens around there, so you can ignore this carbon and these 2 hydrogens. And octane, C8, so you'd have 8 carbons on the backbone and 18 hydrogens peppered around it, and pentadectane would be C15H32, are all found in crude oil. These substances have the same formula. Well, you can see they have a different formula, so that's not true. Have the same boiling point? No. The longer the carbon strand, basically, the more energy required to boil that substance. Are all in the same homologous series. I'll come back to that. Form different products when completely combusted in air. No, whenever hydrocarbon is burnt in oxygen, you produce carbon dioxide and water if it burns completely. If not, you can sometimes get carbon monoxide as well. Now, they are all members of the same homologous series. In other words, they contain the same chemicals, carbon and hydrogen, for example, and when they react, they produce the same product, so they have very similar properties. Chemical properties. Even though the chain length can differ, you can see it's just the same unit repeating itself. That's another sort of feature. Use a word from the box to complete each of the sentences about fractional distillation of crude oil. Each word may be used once, more than once, or not at all. Make sure you pay attention to that. The separation of crude oil into fractions occurs in a fractional distillation column. Before crude oil is passed into the column, it is, and let's have a look, heated. During the distillation, vapour rises up the column until it's cold enough for the vapour to form a liquid. The vapour has been condensed. So, remember, crude oil is just a mixture of hydrocarbons, and what you do is you heat them to a temperature where they all boil, they completely boil, and in a fractionating column, what you have is a temperature gradient, so it's hotter at the bottom and cooler at the top. As these crude oil strands or molecules enter in a gaseous state into here, they'll start to rise up. But as the temperature gets cooler, depending on their individual boiling points, they will condense, they will become a liquid. So the largest strands will become a liquid down here, so you get the thickest fractions here. And then the lightest strands will remain a gas at the lowest temperature, so will finally condense at the top here. So, in other words, the chain lengths you get will be longest down here, the longest hydrocarbons, and down here, as you rise up, the chain length decreases. Complete this sentence by underlining the correct answer in the box compared with the fraction from the top of the column. The fraction from the bottom of the column, you'd say, has more carbon atoms per molecule. In other words, has a longer chain length, which we just looked at. Lower viscosity means it would be runnier. That's not true. Larger molecules form more viscous, more thick liquids. It'd be easier to ignite. No, it's much harder to ignite thicker fuels than thinner fuels. Like petrol is much easier to ignite than, let's say, something like road tar, bitumen, which is very, very thick. When crude oil is separated into fractions, the amount of each fraction obtained rarely matches the demand for that fraction. Figure 4 shows the relative amounts of 4 of the fractions obtained from a crude oil and the relative demand for each of these fractions. So the relative amount obtained from the crude oil, so we can see relatively gas we obtain the least and fuel oil the most, and we can see the demand matches for gas, for petrol, we have a higher demand than we can actually supply. Kerosene, slightly higher demand than we can supply. And for fuel oil, we have a lower demand and we can make a lot more of it. State the fraction for which the relative amount obtained exceeds the relative demand. So obviously that means which one do we have more of in relation to a relatively lower demand? That would be fuel oil. In January 2015, the United Kingdom produced 850,000 barrels of crude oil per day. 45% of this crude oil was fuel oil. Calculate the number of barrels of fuel oil present in 850,000 barrels of crude oil. Give your answer to two significant figures. So what operation is this asking us to perform? We know that we have 850,000 barrels, and we know 45% of this 850,000 barrels will be fuel oil. So how many barrels is this? So basically we're having to work out 45% of 850,000 and give our answer to two significant figures. So 45% of 850,000 is basically just below half. 50% would be half. So I say this because it's really important to have a mental idea of the answer you're going to get, because then you'll know if you're right or completely wrong. So we know it should be roughly 425,000, just below, so roughly 420,000-ish. So decimalize the percentage first. To do this, to find out a percentage of something, you decimalize it. You do that by dividing the percentage by 100. So 45% divided by 100 would be 0.45. Then what you do is you multiply that by the number given. So now multiply 0.45 by 850,000. So if we do that, by the desired value, 0.45 times 850,000 will be 382,500. So that will get you 2 out of the 3 marks. But the next bit says two significant figures. So this is really important. They do this a lot these days. It's a popular thing to do in exams, so please pay attention. Two significant figures means the first two figures, figures which aren't zero. So what you have to do here is you have to look at the number beyond the second figure and see if it is below 5 or 5 and above. If it's below 5, then this number can stay as is. If it's 5 or above, this has to go up 1 to, let's say, 9. Well, it would be 9, but here it's 2, so this can stay as 8. So that means you just basically go 3, 8, and then the rest becomes 0, 0, 0, 0, 0, and that'd be two significant figures. If it was, let's say, 385, then what you'd write instead is you'd write 390000.